Hey everybody, welcome back to Quantitative Reasoning. Today we're in Chapter 3, still working on logic, and this time we're talking about Section 3.2, which is going to be compound statements and connectives. So in this section we will learn what compound statements are, and we'll learn how to express them in symbolic form, and then we'll talk about how to express symbolic statements with parentheses in English, and we'll learn about the dominance of connectives. Here we go. Now, last time in section 3.1 we learned what a logical statement is, and all of the statements that we looked at in the previous section are what you call simple statements. They convey one idea with no connecting words. But statements formed by combining two or more simple statements are called compound statements. And words called connectives are used to join simple statements to form a compound statement. Connectives include words like and, or, if, then, if and only if. These are the main ones, and so mostly what this section is about is learning how to take statements that contain each of these and represent them in symbolic form. So let's start with the connective and. So the symbol for and is this symbol that looks like an upside down V. Of course, it is not really an upside down V, but that is kind of what it looks like. So if P and Q are two simple statements, then the compound statement P and Q in symbols would look like this: P and symbol Q. Also, the English words but, yet, and nevertheless have the same logical meaning as the word and. So you can replace any of these with the word and not change the logical meaning of the sentence. And so any of these would also be represented by this and symbol. Now in English, a conjunction is a word that connects two simple statements. But in logic, the compound statement that is formed by connecting statements with the word and, or any of its equivalents, is called a conjunction. So just keep that in mind. The word conjunction does not just refer to the word between the two simple statements, but it's the whole compound statement where the simple statements are joined by the word and. So let's take a look at example 1, and we're going to practice translating from English into symbolic form. So let's let P and Q represent the following simple statements. Statement P says the office is open. Statement Q says they are working. The instructions say write each compound statement in symbolic form. And our first statement says the office is open and they are working. So the office is open right here. This is statement P. And then we have the word and, so that would be the and symbol. And then the statement they are working, so that's statement Q. So the office is open and they are working. That's P and Q. Now let's look at the next statement, and it says the office is not open, but they are working. So the office is not open, that's the negation of statement P, because statement P said the office is open. So the office is not open, that's not P. But that's the logical equivalent of and. So we'll put the and symbol. They are working. And of course that is statement Q. So the office is not open, but they are working. So that's not P and Q. Okay, let's look at the third statement. They are working and the office is open. So they are working is statement Q, and is the and symbol. The office is open, that's statement P. Now you can see that the first statement and the third statement mean exactly the same thing. So P and Q has the same logical meaning as Q and P. And then the office is open, but they are not working. So the office is open, that's statement P, but that's a logical and. They are not working, that's the negation of statement Q, so that's going to be not Q. And now we're going to take a look at or statements, but the connective or really can have two different meanings, and we need to figure out which one we're using. So think about the statement she visited London or Paris. Now, this actually could mean two different things. It could mean that she visited London or Paris, but not both. And if that's what they mean by that sentence, then that's what's called an exclusive or. Exclusive or means one or the other, but not both. In other words, it excludes the possibility that both things happened. Or what we could mean by this original sentence is she visited London or Paris or both. Like if somebody says to you, she visited London or Paris, but later you find out that she actually went to both cities, I don't think you would probably consider this to be an untrue statement, right? She visited London or Paris or both. That's what's called an inclusive or, because we allow the possibility that both can be true. If both are true, the overall statement is still true. So either or both is what we usually mean by the word or when we use it in English, and also when we use it in mathematics. Unless otherwise specified, the word or means the inclusive or, so that's good news. So again, if P and Q represent two simple statements, then the compound statement P or Q means P or Q or both. Whenever we use the word or, we will be implying an inclusive or. And the symbol for that looks like a V. It's not really a V. You could not type the V on your keyboard and get this symbol, but it does look like a V. And so when we mean to say P or Q or both, then that is symbolized like this, P or symbol Q. And now, just like when we have two simple statements connected by the word and, the whole compound statement there is called a conjunction. When we have a compound statement that's formed by two simple statements connected with the word or, that's called a disjunction. So P and Q is a conjunction. P or Q is a disjunction. Okay, example 2. Let P and Q represent the following simple statements. Statement P says, my book is lost. Statement Q says, my book is in my backpack. Write each compound statement below in symbolic form. So in part A, the statement says, my book is lost, or my book is in my backpack. So my book is lost, that's statement P, or, so we'll put the logical or symbol, my book is in my backpack. So that's statement Q. So my book is lost, or my book is in my backpack, that's P or Q. And in part B, my book is lost, or my book is not in my backpack. So my book is lost, again, is statement P, or, so we put the or symbol, my book is not in my backpack. That's the negation of statement Q, so we will put not Q. Now we're going to move on to if-then statements. So think about the statement, all nurses are college graduates. Just like we talked about in section 3.1, this can also be expressed as there are no nurses that are not college graduates. All nurses are college graduates has the same meaning as there are no nurses that are not college graduates. And another way to say the same thing with an if statement is to say, if a person is a nurse, then that person is a college graduate. The form of this statement is if P, then Q. So statement P here would be a person is a nurse, and statement Q would be a person is a college graduate. So if P, then Q. And a compound statement that's formed by connecting simple statements with if-then is called a conditional statement. And that makes sense because the word if gives us a condition, right? So, like, look at this example. If a person is a nurse, then that person is a college graduate. We can know that the second statement is true if the condition of the first statement is met. And so that's why it's called a conditional statement. Now, the symbol for an if-then statement is this arrow that's pointing to the right. So if we have a statement in the form if P, then Q, that's symbolized like this, P, arrow, Q. So we read this, if P, then Q. The part of the statement that comes before the arrow symbol is called the antecedent. And you probably recognize the anti prefix here, which means before. So that makes sense. And then the part that comes after the if-then symbol is called the consequent. So whenever we have an if-then statement, the part that comes before the if-then symbol is called the antecedent. The part that comes after is the consequent. So it's always if, antecedent, then consequent. And now let's look at example 3 together. And it says, let P and Q represent the following simple statements. Statement P says a person is a teenager. Statement Q says a person is younger than 20 years old. And then the instructions say write each compound sentence in symbolic form. Part A, if a person is a teenager, then that person is younger than 20 years old. So I'm sure you recognize statement P here. So it says if P, then, so we'll put our if-then symbol. Q, this next part is statement Q. So we have if P, then Q. Now I don't want you to think of this if-then thing as one thing causes another to happen. It's not that statement P causes statement Q. It's more like knowing something is true. So if we know that a person is a teenager, then we know that person is younger than 20 years old. But we just don't put the we know part in there because it's too many words. But that's really what's going on here, is that we're saying if we know one thing to be true, then we know the other thing to be true. Okay, so let's look at part B. If a person is younger than 20 years old, then that person is a teenager. So in this case, statement Q comes first. So if Q, then, so we put our if-then symbol, statement P. So this one says if Q, then P. Now notice that if P, then Q happens to be true. If a person is a teenager, then that person is younger than 20 years old. That is true. But when we reversed the statements, we got something that is not true. If a person is younger than 20 years old, then that person is a teenager. That's not true, because there are people who are younger than 20 years old who are not teenagers. Think about somebody who's 5 years old. That person is younger than 20, but they are not a teenager. So just because the statement is true in one sense, it doesn't necessarily follow that if Q, then P will also be true. Okay, here's part C. If a person is not a teenager, then that person is not younger than 20 years old. So a person is not a teenager. That's going to be the negation of statement P. So we will put not P. And then we have our if-then connective. And then the next statement is that person is not younger than 20 years old. So that's the negation of statement Q. So we have if not P, then not Q. And in part D, if a person is not younger than 20 years old, then that person is not a teenager. So a person is not younger than 20 years old, that's the negation of statement Q, so we'll put not Q. And so if not Q, then that person is not a teenager, so that's going to be not P. So if not Q, then not P. In other words, if we know that somebody is not younger than 20 years old, then we automatically know that person is not a teenager. We don't have to ask that as a separate piece of information. If we know this first statement is true, then we automatically know that this second statement is also true. Okay, now you remember in section 3.1 we mentioned a couple of times how English is a very flexible language, and there is very often more than one valid way to put a logical statement into English words. And it turns out there are lots of ways to state the if P then Q relationship in English words, and we need to look at a few of them. So what we're going to do here is get an English statement. In every case, the English statement will be represented by if P then Q, like we have seen already. And then we're going to get an example of that English statement using the P and Q shown here as our two simple statements. So our first English statement, if P, then Q. That's the one that makes the most sense to us. That's the way that we literally read this when we see these symbols, if P, then Q. So that one's the easy one. And our example is going to say if a person is a teenager, then that person is younger than 20 years old. If P, then Q. All right, the next one says Q if P. Now notice that in this case, the Q statement comes first in the English sentence, but it's still represented by if P then Q. So in this case, Q if P. So our example would say a person is younger than 20 years old if that person is a teenager. Q if P. Now I want you to look back up here and notice something. In our first English statement, we had if P, then Q. And when we look at the symbolic statement, the labels are in the same order. So if P, then Q, and in symbolic form, if P, then Q. And in both cases, we get to the P first and then the Q. In this second English statement, it says Q if P. So we have the Q occurring first and then the P. But still, the logical symbolic statement is if P, then Q. So how can the Q and the P be in a different order here than they are here, and both are represented by this same symbolic statement? Well, the reason is that in both cases, the P, which is the antecedent, comes after the word if. So if P, then Q, P is the antecedent. Q if P, because the P comes after the word if, P is the antecedent. Now this is true when if is the only thing between the Q statement and the P statement. We're going to run into only if down here in a minute, but that's a different thing. Okay, as long as we're just dealing with the word if. It doesn't matter whether the if phrase comes at the beginning of the sentence or at the end of the sentence. Whatever follows the if is the antecedent. So that's why we can say Q if P, and it still has the same meaning. And I think when you read that in the example, you can really pick up on that, and you can see that these two sentences mean exactly the same thing. Here's our next English statement. P is sufficient for Q. Now, I know that this is not how we talk in typical English conversation, but you will see this kind of language in scientific reports or maybe even in a news broadcast. You can hear this type of language. So P is sufficient for Q. It just means that if we know statement P is true, that is sufficient. That's all we need to know that statement Q is also true. So in our example here, we would have being a teenager is sufficient for being younger than 20 years old. Or in other words, we might say knowing that a person is a teenager is sufficient for knowing that the person is younger than 20 years old. But even though it's phrased this way, P is sufficient for Q, it still has the logical meaning, if P, then Q. Here's another one. Q is necessary for P. So in our example, being younger than 20 years old is necessary for being a teenager. And that makes sense. Being younger than 20 years old is necessary for being a teenager. In other words, statement P cannot be true unless statement Q is true. Q being true is necessary for P to be true. Here's another one. P only if Q. So in our example, a person is a teenager only if that person is younger than 20 years old. Now, you might not think that the word only makes a lot of difference, but it really does. For example, if you read this statement the way it's written, it's true. A person is a teenager only if that person is younger than 20 years old. But if you take out the word only, okay, just for a second, take it out and read the sentence. A person is a teenager if that person is younger than 20 years old, and we know that's not true. So the word only really does change the meaning of the sentence. And if you think about it, you can see how this sentence has the same meaning as this sentence. In fact, all of these sentences have the same meaning because they're all represented by the same symbolic statement, if P then Q. And there's one more that we won't see as often, but this one says only if Q, P. In our example, it would say only if a person is younger than 20 years old is that person a teenager. Now, a couple of things I want to point out to you because I think it'll be helpful to you in the examples that are coming up. So notice that when you have a statement that's written Q if P, we talked about how that means the same thing as if P then Q, because the same statement is going to come after the word if. But just look at it in this form. When you have Q if P, then when you write that in symbolic form, the order is going to change. So when you see it in the English sentence, it's Q if P. But when you write it in symbolic form, it's going to be if P then Q. Okay, so that happens whenever the word if is all that separates the first statement from the second statement. Q if P gets written if P then Q. Down here where we have the only if, P only if Q, notice that it does not change. So P only if Q is logically equivalent to if P then Q. So when we have only if, the phrases stay in the same order. When we have if in the middle without the word only, when we have Q if P, we write that if P then Q. Okay, same thing for sufficient and necessary. When you have sufficient in your sentence, P is sufficient for Q, then when you write that in symbolic form, the P and the Q stay in the same order. If P then Q. P is sufficient for Q, in symbols becomes if P then Q. The P and the Q don't change order. But when you have the word necessary, they are going to change order. So if you have Q is necessary for P, then when you write it in symbolic form, it's going to look like if P then Q. So when you have the word necessary, the simple statement that comes first is actually the consequent. It actually goes after the arrow. Okay, what we really need right now is an example. So let's look at example 4. And it says, let P and Q represent the following simple statements. Statement P is, I wear my sunglasses. Statement Q is, it is sunny. Now, again, as we're going through these, I just want to remind you, don't think of it as one thing causes the other to happen. Like, don't think of it as somebody wearing their sunglasses is going to cause it to be sunny. That's not the case. But think of it like, if I know one statement is true, then I know the other statement is true. Okay? Think of it that way, like one piece of information gives me another piece of information. So the instructions say write each compound statement in symbolic form. And in part A we have, if it is sunny, then I wear my sunglasses. And so the it is sunny part is statement Q, and the I wear my sunglasses part is statement P. So we literally have here if Q, then P. So we write that if Q, then P. And then part B, if I wear my sunglasses, then it is sunny. So I wear my sunglasses is statement P. It is sunny is statement Q. So in this case we have if P, then Q. And part C, I wear my sunglasses if it is sunny. I wear my sunglasses is statement P. It is sunny is statement Q. Now remember we talked about just a minute ago, when the word if comes in the middle of the sentence, then whatever comes after the word if is actually the antecedent. So this is equivalent to if Q, then P. I wear my sunglasses if it is sunny. If it is sunny, then I wear my sunglasses. This is actually logically equivalent to part A. So if Q, then P. And then part D says, I wear my sunglasses only if it is sunny. Okay, so again, I wear my sunglasses is statement P. It is sunny is statement Q, but this time we have only if. And remember, when we have only if, the order of the statements won't change when you go to symbolic form. So this one is going to say if P, then Q. So look at part B and part D. They are both represented by if P, then Q, so they should mean the same thing. So let's look at B again. If I wear my sunglasses, then it is sunny. So this is saying, if you see me wearing my sunglasses, then you don't have to look outside. You can know without looking that it's sunny. Because if I wear my sunglasses, then it is sunny. If I'm wearing my sunglasses, then boom, automatically everybody can know it's sunny. So, and that's what part D is saying exactly. I wear my sunglasses only if it is sunny. Like, knowing that I'm wearing my sunglasses is enough information for you to also know that it's sunny. If P, then Q. Now notice that part C is saying something a little different. In part C, we still have the P statement coming first, and we still have the Q statement coming last. But the difference is that we don't have the word only here. So in part C, where we had P if Q, we said that's equivalent to if Q then P, because the Q came after the word if. So, but notice that I wear my sunglasses if it is sunny. I mean, yeah, whenever it's sunny, I'm wearing them, but I could also wear them other times too. So I wear my sunglasses if it is sunny. Maybe I also wear my sunglasses if it's Saturday. Maybe I also wear my sunglasses if I'm wearing a purple shirt. I don't know. See, I wear them if it's sunny, but I could also wear them other times. So the only here limits us. So in part C, if you see me wearing my sunglasses, you can't automatically know that it's sunny because something else could be going on. There could be another reason why I'm wearing my sunglasses. I will wear them whenever it's sunny, but I could also wear them other times. But in part D, I wear my sunglasses only if it's sunny. So in this case, if you see me wearing my sunglasses, then you can know for sure that it's sunny. Okay, now we're going to go ahead and talk about if and only if statements. So if you'll remember a couple of examples back, we had one statement that when we wrote it out symbolically, it said if P then Q, and it was true. But then in the next part, we reversed it and it said if Q then P, and then it was no longer true. So we said that you can't always count on the statement still being true if you reverse the antecedent and the consequent. But some true conditional statements will still be true even when the antecedent and the consequent are reversed. So when that happens, instead of having two separate conditional statements, we can combine those two into one biconditional statement. So how does that work? Well, remember just a few minutes ago, we saw that when you have P if Q, so that the word if is all that's separating the first phrase from the second phrase, we said whatever is coming after the word if is actually the antecedent. So P if Q would be represented symbolically by if Q then P. Remember that? And we also talked about only if, and we said if you have P only if Q, then when you write this symbolically, the P and the Q will stay in the same order. So this would be written if P then Q. So here's our pair of conditional statements, and both are true. So if we want to combine them, notice over here, P comes first in both English statements. So if we want to say if Q then P and if P then Q, then what we can do instead, which makes it a little easier, is we can say P if and only if Q. And that combines both of these conditional statements into one. So that's what this line says. If we want to combine if P then Q and if Q then P into one statement, then we say P if and only if Q. Now the symbol for if and only if is a double-headed arrow. So the compound statement P if and only if Q is symbolized by P double-headed arrow Q. So we read this P if and only if Q. So again, the compound statement that you get from connecting two simple statements with if and only if is called a biconditional statement, because two things have to be true in order for the statement to be true. It has to be true that if P then Q, and it also has to be true that if Q then P. So that's two things, so biconditional. Now it won't come up very often for us in this class, if at all, but it's not unusual for the phrase if and only if to be abbreviated by IFF. And so if you ever see this, it's not a typo where somebody accidentally typed a second F. What you're seeing here is an if and only if statement, but it's abbreviated instead of being typed completely out. Okay, let's look at some of the different ways that the English statement can appear when you have a biconditional statement. And as our example, this time we'll use statement P, an animal has feathers, and statement Q, an animal is a bird. So I guess the most obvious way to represent the biconditional statement is just for it to say if and only if. So P if and only if Q. With our example here, that would say an animal has feathers if and only if the animal is a bird. So that's pretty straightforward, but it would mean exactly the same thing if we said Q if and only if P. See, because the relationship has to work both ways, it does not matter which simple statement comes first. They both imply the same thing. So we could also say an animal is a bird if and only if that animal has feathers. And both of these statements are logically the same. Another way to put it would be to not abbreviate, but just make both complete statements. If P then Q, and if Q then P. So in our example, that would be if an animal has feathers, then that animal is a bird, and if an animal is a bird, then it has feathers. So again, you see that using if and only if is just a way to shorten the sentence, but it has the same logical meaning. Now, when we were doing conditional statements, we learned about if and we learned about only if, but we also talked about sufficient and necessary. So another way to say P if and only if Q is to say that P is necessary and sufficient for Q. So we could say an animal having feathers is necessary and sufficient for the animal to be a bird. And so you could have P is necessary and sufficient for Q, or you could have Q is necessary and sufficient for P. So our example could say that an animal is a bird is necessary and sufficient for the animal to have feathers. See, it does not matter which simple statement comes first because they are both necessary for the other condition to exist, and also they're both sufficient. So we can put either one first that we want to. So here is example 5, and it says, let P and Q represent the following simple statements. Statement P, today is my birthday. Statement Q, Mom made me a cake. Write each compound statement in symbolic form. So part A says, Mom made me a cake if and only if today is my birthday. So Mom made me a cake, that's statement Q. Today is my birthday, that's statement P. And of course the if and only if is going to be represented with a double-headed arrow. So Q, if and only if P. Then in part B, today is my birthday, if and only if Mom made me a cake. So today is my birthday, that's statement P. Mom made me a cake, that's statement Q. And so in this case we would have P if and only if Q. Now again, because this is a biconditional statement, it doesn't matter which condition you state first. The statement has to work in both directions. So these two are equivalent, and if one is true, the other one is always true. Part C, today is not my birthday if and only if Mom did not make me a cake. So today is not my birthday, that's the negation of statement P. So this part right here would be not P. And then Mom did not make me a cake, that's the negation of statement Q, so this part would be not Q. And so then we would have not P, if and only if, not Q. Part D, today being my birthday is necessary and sufficient for Mom making me a cake. So today being my birthday, that's from statement P, and Mom making me a cake, that's from statement Q. Remember, necessary and sufficient means the same thing as if and only if. So necessary and sufficient gets us that biconditional part. So P, if and only if, Q. And then part E, Mom making me a cake is necessary and sufficient for today being my birthday. So Mom making me a cake is statement Q. Today being my birthday is statement P. So in symbols, this sentence would be Q, if and only if P. Okay, we have covered a lot of ground here, so we're going to kind of sum up all of the different types of logic relationships we've looked at in their symbolic form, and then we'll look at some common English translations for each of those. And we're going to start off with the negation, which we talked about in the last section, but we've used it in this section as well. And you know that the symbolic form for the negation is just to put a tilde in front of the label for the statement. And so the way that comes across in English is not P, or it is not true that P. And then earlier in this section we talked about the conjunction, and we said a conjunction was two simple statements joined by an and the symbol for that was the upside down V looking symbol. So this is read P and Q. So it can look like that in English, P and Q, but we said it could also be P but Q, or P yet Q, or P nevertheless Q. And then we talked about the disjunction, and we said a disjunction is two simple statements joined by an or. Okay, so that would look like this, P or Q. So remember that the symbol for or looks like a V. So the and symbol looks like an upside down V, and the or symbol looks like a V sort of. So P or Q. And it could be said that way in English, P or Q, and that's really the only way we have to represent that kind of situation. Okay, the next type of logic relationship that we talked about was the conditional statement. And so we could have if P, then Q. And that came across several different ways in English. So we could have just if P, then Q. We could also have Q if P, or we could have P only if Q. And we also looked at P is sufficient for Q and Q is necessary for P. All of these are represented by the logical statement if P, then Q. And then finally we had the biconditional statement, which just has the double-headed arrow, so P if and only if Q, and it can be written that way in English, but we also saw that it can be written as P is necessary and sufficient for Q. Okay, here is example 6, and this will be a good one for us. I think this will help you a lot. This one says, let P and Q represent the following simple statements. Statement P says it is Monday. Statement Q says I have a meeting. And then it says write each symbolic statement in words. So part A is not P and Q. So not P would be it is not Monday, and then this symbol here represents the word and then Q would be I have a meeting. So it is not Monday and I have a meeting. And then in part B, we have an if-then statement. So if P, then not Q. So if it is Monday, then I do not have a meeting. If it is Monday, then I do not have a meeting. If P, then not Q. And then part C says P or not Q. P or not Q. So P would be it is Monday or not Q. So that would be I do not have a meeting. It is Monday or I do not have a meeting. And then for part D we have a biconditional statement. So not P if and only if Q. So not P will be it is not Monday if and only if I have a meeting. And then we'll continue the same kind of thing in example 7, only here we have some parentheses sneaking in. So this one says, let P and Q represent the following simple statements. Statement P, he is young. Statement Q, he is in good health. Write each symbolic statement in words. So part A is the negation of P and Q. The negation of P and Q. So because the P and Q is in parentheses, the negation applies to the whole thing. So what I would want to do in that case is probably just form the negation by saying it is not true that he is young and in good health. And I think by putting it this way, where we don't repeat the subject of the sentence, it helps underline that the it is not true applies to everything that comes after the word that. It is not true that he is young and in good health. Then in part B, it says not P and Q. So in English words, we could say not P would be he is not young, and then this would be an and then statement Q would be he is in good health. So he is not young and he is in good health. Or remember that this conjunction situation can be translated to the word but. So we could have said he is not young but he is in good health. And they logically have the same meaning. And then part C is asking for the negation of P or Q. So the negation of P or Q. So again, I think I would start by saying it is not true that, just to show that everything that comes after the word that is going to be negated. So it is not true that he is young or he is in good health. Or I think you could get the same meaning by leaving out the subject in the second part of the sentence. So I think you could say it is not true that he is young or in good health. Now, there is another way to write this sentence that may be more natural to the way that we talk, but it wouldn't look so much like the symbolic statement that we have here. But I think it would carry your meaning better. So, it is not true that he is young or in good health. What you're trying to say here is that neither one of these things is true, right? So, what you could say is, he is not young, and he is not in good health. So again, writing it in this form doesn't really look like the symbolic statement that we have here, but it does have the same meaning, and this probably gets your meaning across a little better for most people. Okay, here is example 8, very similar to example 7. So if you want to stop the video and try this one on your own, I think that's a great idea. And now if you've had a chance to do that, I'm going to go through this one with you. So it says, let P and Q represent the following simple statements. Statement P says she is wealthy. Statement Q says she is happy. Write each symbolic statement in words. So in part A, we want the negation of P and Q. So it is not true that she is wealthy and she is happy. Or you really don't have to repeat the subject here. You could just say it is not true that she is wealthy and happy. Then in part B we have not P and Q. So we could say she is not wealthy and she is happy. Or because one is negative and one is positive, what we would probably say in English is she is not wealthy but she is happy. and that's the same, that's logically equivalent. Then for part C, we want the negation of if Q then P. The negation of if Q then P. So remember that to form a negation, we just insert the words "it is not true that" in front of our statement. So it is not true that if she is happy, then she is wealthy. It is not true that if she is happy, then she is wealthy. Now, many compound statements contain more than one connective. And as long as the statement is expressed symbolically, parentheses are used to indicate which simple statements should be grouped together. But we can't have parentheses in a word sentence. So when the statement is expressed in English words, we'll use commas to indicate the groupings. So let's look at a couple of symbolic statements that contain parentheses and see if we can get the English translation. And where there are parentheses, we'll pay attention and make sure that we put a comma in the right place so that the grouping is the same in the English translation as it is in the symbolic statement. So if you look at these two symbolic statements, they are exactly the same in every way. They have all the same statement labels and they have all the same connectives, but the only thing that's different between them is the grouping. So in this first one, we have the Q and not P grouped together. And then we have this if-then connective here. So when we do the English translation, we are going to put a comma where the parentheses end. So, and notice that this is an if-then connective. So we're going to say if Q and not P, comma, then not R. You see the comma goes at the place where the parentheses closed. Now in this second statement, it's the if-then part that's grouped together. So the statement to group together is the if not P, then not R part of the statement. And here we have an and connective. Now I know that the parentheses start after the and symbol, but in English we always put the comma before the conjunction. So when we go to the English translation here, it's going to be Q, comma, and if not P, then not R. See, the comma is showing us that everything that comes after the connective, after the word and, is going to be grouped together. Q, comma, and if not P, then not R. Okay, so here's example 9, and it says, let P, Q, and R represent the following simple statements. Statement P, a student misses a lecture. Statement Q, a student studies. Statement R, a student fails. And then it says, write each symbolic statement in words. So we will need to make sure and put a comma in the correct place in our English statement to indicate where the grouping is in the symbolic statement. So let's take a look here. Inside our parentheses, we have Q and not P. So Q is a student studies and not P would be a student does not miss lecture. And then we've got this if-then connective. So we're going to start with the word if. So, and then what comes next is Q and not P. So if a student studies and does not miss lecture, comma, because right here is where our grouping ends. So we're going to have a comma. Then not R. So our English statement will say then a student does not fail. And let's look at part B. So here in part B, we have the if not P, then not R part of the statement grouped together. And so we'll start with the Q. Statement Q says a student studies. And then we're going to have the connective and before our if-then statement. But remember, since this if-then statement is grouped together, we're going to need to set it apart with a comma, and the comma needs to come before the word and. So a student studies, comma, and if a student does not miss lecture, then a student does not fail. So you see where the comma goes. We needed a comma because the comma shows that we have this grouping here, but we needed the comma to come before the word and. And now here is example 10, so it's very similar to example 9. In fact, if you wanted to stop the video and try this one on your own, that's a really good idea. And now I'm going to assume that you've had a chance to do that, and let's go through this together. So it says, let P, Q, and R represent the following simple statements. Statement P, scientists develop a vaccine. Statement Q, all people are vaccinated. Statement R, the disease is eradicated. Write each of the symbolic statements in words. And again, both of these statements contain parentheses, so again we'll have to make sure and place a comma so that it indicates where the grouping should be. In part A, we have an if-then statement, and the part of the statement before the if-then connective is in parentheses. So we're going to have if P and Q. So if scientists develop a vaccine and all people are vaccinated. And then that's the end of the parentheses. So we need to indicate the end of the grouping with a comma. Then R. So we'll have then the disease is eradicated. And then let's look at part B. So again, we have an if-then statement, and we have this not P or not Q part grouped together. So we'll need to place a comma to show that this part of the statement is grouped together. Now again, because of the if-then statement, we will start with the word if. So if not R, if the disease is not eradicated. Now what comes next is the word then, followed by our part of the statement that should be grouped together. So we'll need a comma here. So comma, then, not P or not Q. So then, scientists did not develop a vaccine, or all people are not vaccinated. And here's part C of example 10. And so we've got the same three statements here. And this time we have our if-then statement inside the grouping symbol. So we will place a comma in the appropriate place to show that this part of the statement gets grouped together. So it's going to be P and this part of the statement in parentheses. So we're going to start with scientists develop a vaccine, and the next word will be and, but what comes after the and is grouped together. So this is the place to put the comma, then the word and the part that's in parentheses is going to be if Q, then R. So if all people are vaccinated, then the disease is eradicated. And now let's talk just a little bit about dominance of connectives. So basically this is order of operations for your logic symbols. It's the same idea as order of operations. It's just a way to know which connectives should take precedence over the others when we don't have parentheses to show us which one gets precedence. So if a symbolic statement appears without parentheses, then statements before and after the most dominant connective should be grouped. So here is the order for dominance of connectives. The biconditional is the most dominant connective, followed by the conditional statement. So if you have a biconditional, that's the most important. If you have a conditional, that comes next. The conjunction and the disjunction are after that, and they have the same level of dominance. So the and the or are equal in importance, and then after that you have the negation, which is the least dominant. So biconditional, conditional, conjunction and disjunction are of equal importance, and then negation is the least dominant. So let's practice using the dominance of connectives just a little bit. What we're going to do is look at a series of statements and figure out what the most dominant connective is, and then we will insert parentheses in that same statement to clarify the meaning. Because remember, dominance of connectives plays no role at all unless we have a statement without parentheses. Because if you have parentheses, then they tell you what has to be grouped together. But if you don't have parentheses, then you have to figure out what should be grouped together. So that's what we're going to do here. And then we will insert parentheses to not change the meaning, but just make it clearer. And then we'll know what type of statement that we're dealing with. So this first statement has a conditional in it. So it says if P, then Q, and not R. And notice there are no parentheses here. So what we have to do is figure out which connective is the most dominant, and then we'll group together everything that comes before it and everything that comes after it. So the connectives we've got here are the conditional, the conjunction, and the negation. Or we could say the if-then, the and the not. Okay, well, thinking about the list that we just saw on the last slide, we know that the conditional is the most dominant connective. So I've highlighted that in red here. And now that we know which one is the most dominant, we know that everything before it would be grouped together and everything that comes after it should be grouped together. So before the if-then connective, all we have is a P, so we really don't need parentheses for that. But we do want parentheses around this Q and not R part. So over here, in the next column, let's write the same statement, but just put your parentheses around the Q and not R part of the statement. And so now you can see that it says if P, comma, then Q and not R. And because the conditional is the most dominant, this is considered a conditional statement. The type of statement is always whatever connective was the most dominant. So let's look at this statement. This one also contains a conjunction, a conditional, and a negation. And the conditional is the most dominant. So right here in the second column, we will highlight the conditional. And now we know that everything before the conditional should be grouped together and everything after it. But after it, we really don't need parentheses because there's just one thing there. So when we go to the next column, what we're going to do is put the P and Q part in parentheses, and now we know how this statement should go. It would be if P and Q, comma, then not R. And again, because the conditional is the most dominant connective, this is a conditional type of statement. Okay, here on the third line, we have a biconditional and a conditional. And so we know that biconditional takes precedence over conditional. And so right here we're going to highlight the biconditional connective. And that means that everything that comes after the biconditional needs to get grouped together. So before the biconditional, we only had the one variable. So we really don't need parentheses there, but we do need parentheses around the if Q then R part of the statement. And because the biconditional is the most dominant, we'll say this is a biconditional statement. On the fourth line, the statement is very similar. We still have a conditional and a biconditional. So of course the biconditional is still the dominant part of the statement, but this time what comes before the biconditional will need to be grouped together. So over here in this column, let's put parentheses around the if P then Q part of the statement. And again, because the biconditional is the most dominant, this is considered a biconditional statement. Okay, our next statement contains a conjunction, a negation, a conditional, and a disjunction. Now we know that the conditional is the most dominant, and so here in the second column we're going to highlight the conditional, and we know that everything that comes before the conditional should be grouped together and everything that comes after it should be grouped together. See, up here that wasn't necessary because we only had one thing before the conditional, but down here we have things before that need to be grouped together and things after. And so when we go to the next column to put our parentheses, we will put all of this in parentheses before the conditional and all of this in parentheses after the conditional. So this statement would say if P and not Q, comma, then R or S. And because the conditional is the most dominant, this is a conditional statement. And then finally, let's look at this statement. It says P and Q or R. Now the problem here is that there's not a most dominant connective. We only have and or, and they are equal in dominance. And so we have no way of knowing just from what's written here what the writer intended. We don't know how it's supposed to go, so the meaning is ambiguous. The person that wrote the statement would have to put in the parentheses because there's no way for us to tell as the reader how it's supposed to go. So question, when am I supposed to use the dominance of connectives? And we talked about this. The only time it's important is when you don't have parentheses in the statement. So we only apply the dominance of connectives if grouping symbols, in other words parentheses, are not given in the compound symbolic statement, or commas do not appear in the compound English statement. If we have commas in the English statement, or if we have parentheses in a symbolic statement, we won't need to think about dominance of connectives. But if both of those things are missing, we'll have to use the dominance of connectives rules to figure out what's intended. So here is example 11, and it says write each compound statement in symbolic form. Part A says, I do not fail the course if and only if I study hard and I pass the final. And then it says write the statement in symbolic form. Well, in order to do that, we need to figure out what P, Q, and R are. So let's go back to the sentence and see if we can figure out what our logical statements ought to be. The first part of the sentence says, I do not fail the course. Now, you could say that statement P is, I do not fail the course, but remember, it's easier for us if the statement is positive and the negated statement is negative. So I don't want to call this statement P because it contains the word not. Instead, what I'm going to do is I'm going to let P be the statement I fail the course. That way not P will be I do not fail the course. I think that'll be easier for us to keep straight in our heads. And then statement Q can be the part I study hard. And then statement R would be I pass the final. Okay, so notice there are no commas here. So what we're going to do is write it down in symbol form just the way it is, and then we'll figure out where to put the parentheses based on the dominance of connectives rules. So I do not fail the course, that's going to be not P. If and only if, that's a biconditional. I study hard and I pass the final, that's going to be Q and R. Okay, now let's look at this. The connectives that we have are the negation, the biconditional, and the conjunction. So the most dominant connective is the biconditional. That means everything before the biconditional would be grouped together, but there's only one thing there. And everything after the biconditional will be grouped together. And so just for clarity, I'm going to put that part in parentheses. Notice that the parentheses don't change the meaning of the statement, but they do make it a little easier for someone who's reading it to understand what's being communicated. And then part B, I do not fail the course if and only if I study hard, comma, and I pass the final. Now this is exactly the same statement as part A, except that it contains a comma, so it's going to tell us where the grouping should go. Okay, so the comma tells me that everything that comes before the comma is to be grouped together. So here we're still going to have not P, if and only if Q, but that comma tells me that these things should be grouped together. So I'm going to go ahead and put that in parentheses. And then and I pass the final is statement R. So here we have I do not fail the course if and only if I study hard and I pass the final. See, up here in part A, where we did not have a comma, the passing the final was part of the condition that had to be met in order to not fail the course. But down here, that's not the case. Passing the final is outside of the if and only if statement. Okay, just a little more practice. Here's example 12, still practicing with the dominance of connectives. So it says write each symbolic statement in words. If a symbolic statement is given without parentheses, place them as needed before and after the most dominant connective and then translate into English. So statement P says the temperature is above 85 degrees. Statement Q says we finished studying. And statement R says we go to the pool. Okay, so looking at part A, we have this P and Q part grouped together, and we have this conditional connective. So that's an if-then. So we're going to start our statement with the word if. So if P and Q, if the temperature is above 85 degrees and we finish studying. Now, that's the end of the grouping. So now we put a comma. And what comes after that is then R. Then we go to the pool. So if the temperature is above 85 degrees and we finish studying, comma, then we go to the pool. And then in part B, we have almost the same statement, but not quite because the grouping is different. So here we have P and if Q then R. So when we translate that into English, we have the temperature is above 85 degrees. Now what comes next is and followed by this part that should be grouped together, and we know that we always put the comma before the word and. So comma, and if Q then R. If we finish studying, then we go to the pool. Okay, part C has no parentheses, so we'll need to use our dominance of connectives here to do the grouping before we translate into English. And you can see that this is a conditional statement, so that looks like the most dominant connective. So I'm going to go ahead and put parentheses around the not P or not Q part of the statement. And now I believe we can translate into English. So we're going to have to start with the word if. So if, not R. So if we do not go to the pool. And what comes next is in parentheses. So comma, then the temperature is not above 85, or we did not finish studying. Not P or not Q. And then finally part D, we do have parentheses here, so we don't need to think about the dominance of connectives, but this will be an or statement. So this is primarily a disjunction. And so we'll start here by saying if not R, then not Q, and we'll follow that by a comma. So if we do not go to the pool, then we did not finish studying, comma, or the temperature is above 85 degrees. Okay, guys, I know that was quite a large section, and we've learned a lot. We've covered a lot of ground. It's going to take you a little practice and a little time to digest it all and work on it enough where you're confident with it. But I believe you can do it, and I want to encourage you again, reach out to your instructor and ask any questions that you need to. Get all the practice that you can in my lab, and I'll see y'all in the next section. Bye.